Alright, I know it's been a while since I made a video, and try using my phone here and see how it goes. Got this mezzanine built. I've been throwing a bunch of stuff up there, so I got a lot more room, though now I've made a mess out of wood. But moved that shelf out of the way, cleaned up the garage, and there's still plenty of stuff that can go up above. I gotta finish some of the wiring. But this has been driving me crazy, so I figured I need to get something done on this hub dyno. I figured I'd come out here and see what I could do for a little bit. Kind of play around with some dimensions. Of course, I have that CAD model I'm gonna reference as well. I just kind of look in here. Looks like if it was, you see that mounting surface up there. Just kind of looking if I had it at, say, 12-inch lever arm, and it looks pretty good. I'll have to go back to the CAD and see what I made it, but should be able to put the mount for the strain gauge. This is rotated, of course, 90 degrees. These will actually be on the sides. But looks like that'll give me a few inches to put like a clevis pin or something for the strain gauge, and then that would be a perfect 12-inch lever arm, or 1 foot. I'll have to go back and see how much force that would be on the load cell. If it seems excessive, then I might make it a little longer, but I would like this hub dyno to be kind of as compact as possible. And I don't really plan on doing any real high horsepower cars with it for now, so I figured I'd start with just making basically those supports that are gonna, if this was the bottom frame, making the supports that come up and bolt the pillow blocks to. And my plan is, I have a abrasive cutting saw, so I'm gonna see how straight that's able to cut a 45, because I want everything to be cut at a 45 so that they're closed in, like mitered together, if that makes sense, instead of having just like an open tube and then a vertical tube welded to it. I think it'd be a lot cleaner to have those, I guess, mitered ends welded together. I was just kind of looking at this pillow block. It's pretty much right at 8 inches. So what I think I may do is go ahead and add 3 inches to both sides, since I got 3-inch tubing. And what they'll let me do is that I can weld nuts on the inside of that tubing, but what I may do is drill with the milling machine all the way through the tubing and weld in a tube, like a small round tube, through the square tubing, so I can use bolts and nuts instead of trying to weld a nut inside that tube. Another advantage of that is, if you have a longer bolt or stud or whatever it is, then you can put more preload or more stretch in that bolt. So even if the torque value is the same, when you torque a longer bolt, you're going to end up effectively stretching it more. And that really helps with keeping the clamping load more uniform or the same. So, there's going to be some vibration. There's always some vibration in every mechanical system. And if you have a real short bolt, which would just be, these are pretty large bolts that are going to go through here, but they're only going to be, effectively a ½ inch until you get to the threads inside that tubing, you don't have a lot of stretch there, and it's very easy for that bolt to come loose because it wouldn't take much change, in the, say, the compression of this iron block here, or vibration basically, to loosen that bolt. I just feel a little better than blindly welding a nut on the inside upper surface of that tube. It's probably not necessary, but if I make it come out 3 inches, that gives me the option to do either or, basically. So I like having options. Alright, so I'm just gonna mark out a 45 off of here. It's one thing I don't really like about this kind of tubing. It has the big radius, which has lots of benefits, but it just makes it harder, I think, to kind of lay out. Try my best to lay this out. I'm not a fabricator, so doing my best, okay? But grab the line there, and 14 inches to this line, and then a 45 that way. So now the fun part is trying to cut that, because these tubes, I think, weigh 110 pounds a piece. Well, for better or worse, this is the saw I have. It's like, I think it's Chicago Electric, so it is from Harbor Freight, and it is used, but it does work. And we'll see if this 3-inch square tubing will kill it. I had to, of course, bring this side up and then get it nice and level with the table. So that looks pretty good. Then I'm leaving about really only like a 1/16 of an inch there. Well, I don't think this saw is going to do it. Well, it did make it through, but that's not working. Let me grab the plasma cutter, I suppose. I got a feeling this build might make people unsubscribe, because that's the first time I used that plasma cutter, and 50 amps is its highest setting, so I don't know if that's part of the issue or what. Probably also my lack of skill. I've used it before, actually. I've used it on very thin sheet metal and goes through that like nothing. This 1/4-inch tubing is another story for me. So as you can see, I did cut it, though I've seen people do a whole lot better with gas torches. So probably should have used a guide, and I'll try using a guide next time. So yeah, not very pretty at all, but I guess the milling machine will take care of that. I did leave probably more than I needed to. There's about a 1/4 inch going around there, only maybe about 1/8 up there, and not much right there, but that's where the saw was cutting. So yeah, and I guess go over to the milling machine and see see what I can do with this. Alright, we're here at the milling machine, and I got a 3-inch end mill there. And I've already done a few of these, so here's one of the vertical pieces. That's 9 inches. I was using the plasma cutter. I didn't use a guide on this one, but it's not really turning out so well, so I just used a hand angle grinder. Yeah, that's actually that's not too bad. I'll take that anyways. So I might just buy a new abrasive saw. They're a lot cheaper. And use the abrasive saw to cut these and then finish them on the mill here. Because this takes quite a lot of time, so I'd rather, if I have to finish it up on the mill, I'd rather only take one pass or something. As you can hear, all that squealing, it's not actually coming from the machining. Coming from the, I don't know, the electric motor up there or the variable speed mechanism. So I guess I'm gonna have to look into that. I just really don't want to tear this machine apart right now. Be careful not to crash it. It's still clearing, but just barely. Hey there, we got clean up all the way across there. So I'll flip it around and do the straight side and get it up to the right length. Alright, here's the 2 vertical pieces. Yeah, they are pretty dang perfect. Here's yeah, something like that. So basically that's how that's going to come together. I didn't do a very good job of centering it up. It's all just sitting there. So this probably won't be much higher off the ground than it is now, because to the top of this pallet's 5 inches. And of course I'll have to add the wheels or rollers, so it will come up a little bit, but that's 3-inch tubing. And then once I get done duplicating it for the other side, I'll make 2 more for that one. But I think this is going fairly well. It's pretty slow with using the milling machine. I'm gonna go buy a new abrasive chop saw, and then maybe I can just take off an 1/8 inch or less on the milling machine. Anyhow, thanks for watching. I just wanted to show some progress on this. I'm gonna keep working at it, and still got that much material left, so we'll see.